Alright, we are right into logs, logarithms, which is just logs for short. And yesterday we spoke about exponential form into log form into exponential form. And then I said to you the technical definition is if y is equal to x, a to the x, that was your exponential graph. Very basic, without d here, without t being moved up and down or left and right anyway. So if that was the exponential form, then the log form would be x is equal to a to the y, meaning y is equal to log base of a, and then the x there, all the technical stuff. That a is not allowed to be 1. That a is not allowed to be 1. That x is not allowed to be negative. Are you with me, everybody? Right, all the technical stuff. And then I said to you, if you can't remember that and how to do that, take something very practical like 2 to the power of 3, that's equal to 8, because you can check yourself on it. You know that 2 to the power of 3 is really 8. So to take that into log form, we're going to say the exponent is going to be the subject. The log of and the base will still be the base of 2. And then the worst thing that can happen to you is you're sitting there and you don't know, should the 8 be on the other side and the 3 swap with it? How will you know that you are right? You take your calculator and you punch into your calculator log 2 of 8, and it does give you 3 and you know you're right. If you swapped it around, it wouldn't be true, so you know that that's your mistake. It's just a practical tool I'm giving you to know what the definition says. So that yesterday, very silly question, write this into log form. So it's 3 to the power of 1, they wrote it there like that, 3 to the power of 1. And we're going to go into log form because 1 is going to then be equal to, the exponent is now the subject, log of 3. Base of 3 of 3, and it's something that you know, right? Because this was the question, write it into log form. Guys, this is not sums that you can expect in a test. This is just getting you into the whole way of writing logs. But is this true?
Yes.
It's one of your whole list of things that you now know about logs. That if it's log, same base, same number there, it will be equal to 1. A few things that I've already talked about. Because that log base of 3 can be split up into log 3 over log 3. Right? What are those bases there?
1 and 1.
Not 1. 10. Those bases will be 10. Right. Okay, let's carry on to this one. Let's go into the log form. What must I write? Negative 4 is the exponent, is now the subject. Log of 2 and then 1 over 16. And can you test it? Well, that was true, 2 to the power of negative 4. How will you test this? Punch it into the calculator because it's actual numbers, and the answer has to be negative 4. With number 2e, unfortunately, there's no testing here. You'll have to know it's right. So we're going to say exponent is the subject, or the base is going to be still a, and that should be a x. Now you can't test that. You've got to know that it's correct. Let's go from log form into exponent form. Still just going from here to there, the other way around. So then the base will still be the base, getting back to an exponent. So it'll be a to the power of 3rd, that gives me 2, and you can double check that because it's numbers. Because it's actually 8 in a cube root, right? Power of 3rd is actually a cube root of 8 is equal to 2. Done. What are we doing here? Sums? No, just going from the one form into the other form. What are we doing with this one? The base will stay 2, the exponent is now negative 2, answer is equal to a quarter. So that will be your subject, and 2 to the power of negative. So is this true? 2 to the power of negative 2 is a quarter, something that you know from long ago in exponent rules. Okay, this one now is the problem. You can't test it on a calculator. we're going to write that a to the power of q is going to be equal to p. Does it matter that I put the p to the left or equal to the right? It doesn't matter. Are you all with me? Right, we need to get into some more of these sums. Guys, technically, the log laws aren't really for examination purposes. I can't examine them deeply because there are equations, there's even log inequalities that used to be part of the syllabus. It's not anymore, but I'm touching on it just so that you've got a basic idea when something like that occurs. I'm saying solve for x, because remember I'm focusing on the graphs. Where are logs going to be required from you? I'm going to do it in the graphs. Most of the time, statistically spoken, we've seen them go to the exponential graph and then say sketch the log graph, or the other way around. Sketch the log graph, get to the exponential graph, because they go hand in hand. Those inverses go hand in hand. Everybody with me on that? Okay? So when they ask you to solve in one of those sums, where the log graphs are equal to, you can actually do them with a little sum. But most of the time you just read it off the graph. Okay, so this is a little bit over the top, a little bit extra. But would you be able to solve for x here?
Yes, ma'am.
How would you do this?
Into exponential
Because
form.
basically we've been doing it here all along. We've just not solved an unknown variable. The unknown variable is now x. And how would I get to that x?
X.
X to the power of 3 is 27. And how would you get x now?
Make 27.
Okay, 27 you can make.
3 to the
3 to the 3. And then make a deduction.
Remove your X.
Okay, just make the deduction.
X plus
X is 3. What you are doing is you can go cube root then, it's fine. X is 3. Or from there, you could have said, well, x is then the cube root of 27, which also gives you 3. There's many ways of thinking about it. But the main thing is you had to go from log form into exponential form. Then you could solve it. Old news. So let's try the next one, because now there's a little bit of a problem here. If you want to go from log form into exponential form, how are you going to do this one?
Take
2 and the exponent is the whole x plus for everything is equal to 4, right? Then what would we do? So do you see that logs and exponential equations go hand in hand? So we're back to exponent laws, an exponential equation where we always used to get the same basis by prime numbers. So x plus 4 is 2 and x is equal to?
-2.
Can you test this sum? So if you substituted this x with -2 and you got 2 as an answer, and you put that into your calculator, you would get 2 as an answer as well, then you know that your sum is right. But those are the log laws, just a little bit. Okay. Alright guys, so I'm going to give you a little bit of a background on logs. Those of you who are going to go and write the NBT tests because you want to go into engineering and you want to go into medicine, etc., you have to go write NBT, National Benchmark Tests, at some other university. You've got to make an appointment. Some of you might have even done that already. So when you do go and write that, you go without a calculator. You're going to know that. And sometimes they do have a little bit of this log background in there, which is actually not school syllabus anymore. So I'm just giving you a little bit of a background, not too much, not in depth, because you don't really need this in an exam in grade 12. Are you with me? Putting you in the picture here. So I'm just giving you a little bit extra here. Now, first of all, I want to say something about just log. In your calculator, you have two log thingies. One that says something, and one that just says log. So there's a difference. If there's nothing there, like here, then there's a 10. Not a 1, a 10. So over here I want to make this note in color. But whenever there's no footnote there, no base there, then it's a 10. But we always think it's a 1, right? It's not a 1, it's a 10. It's a given thing in logs. that if there's nothing there, there's actually a 10. Are you with me? So, in other words, if I go here, I could then go and put the 10 in myself, or I can put nothing in and just put log whatever the question was. And there can now be answers that you've got to round off to 2 decimals, and your answer will be something like 7,3, whatever, with your logs. Can happen like that. Another thing that can happen is the exponent, because logs and exponent goes hand in hand. That exponent, there's a law that says that that exponent can go sit right here in the front. So you can write it as k log base of m. Now you've got to write this correctly. This is a base. This is on the same space as the log. That's an exponent. So an exponent can go stand in the front, and if I need it, because I'm working with other stuff, I can even put it back up there again. Different log laws. With numbers, with variables, doesn't matter, but it's a law. Okay? Log 1, please take your calculator. So you can go to this one, right? If you go to this one, you've got to put the 10 down there. Okay, log 1 is equal to? 0. Okay, so you've got to know that log 1 is 0. Log 1 is 0. A to the 0 is 1. Think about it. Let's take it into logs. So this will be log of the base of A. What did we just say? But it doesn't really matter what that base there is, log 1 is going to be equal to. What did I prove here? Something that you know, into log form, it doesn't matter what that A is, this answer will be equal to 0. Are you with me? A lot of information that you're not going to really use. Okay, then another thing. If it's then log something at the bottom, something at the top, you're allowed to, obviously for certain reasons, split them up into log B at the top and log A at the bottom. No other way. It's that one at the top and that one at the bottom. And then those bases again are 10. Okay? So why would I want to do this? If you're going into those sums, you are going to use it, alright? So the facts are, you can split them or you can put them back together, squash them back together. So now, coming from there, I want to ask you a question. If this bottom one is a 1, then if you split it up, this answer is going to be? But log 1?
So the base can never be
So it's undefined.
And that's why right in the beginning when we wrote it down, I said to you, this is the rule. That thing must never be 1. Because then you're going to get undefined. That's why it cannot be 0. Because that is undefined. That can never be 1. Because when you split them up, you're dividing by 0. That's the reason why it cannot be 1. Okay, so now let's come back again and say, well, if I split them up, log m over log m, then this would be equal to?
Okay, it's 10.
If I split them up, log m at the top, log m at the bottom, that answer is?
1.
Are you following me here? Because if I split them up like that, then log m over log m, anything divided by itself? So we're making a deduction here that if ever that is log 5 of 5, that will be equal to?
1.
You getting here?
Yes, ma'am.
Whether you split them or not, you must know that if those are the same, the answer is going to be 1. Just always be careful, this bottom one cannot be 1. Otherwise it's undefined. Now let's get to some stuff that you actually use a little bit sometimes. And that's the fact that log 10 will be equal to what? Keep in mind, there's nothing here.
There's a 10.
So there's 10.
1.
So the answer is going to be
1.
1. Are you with me here? Now, let's go for log 100. Now I'm going to show you some of the techniques. Let's make the 100 10 square. And then let's use this one. So man can teach you what log 100 is. Guys, you've got calculators, right?
Yes.
So you could have put in your calculator log 100, it would have given you 2. Okay? Okay, but I'll have to teach you this. Why is it 2? Because 10 is, 100 is 10 squared, and I can take that 2 and do what to it? Put it in the front. So that's going to be 2 log 10, and you've just established that that's log 10 of 10, which gives you 1. So that whole answer is 2. So what am I deducting? Log 10 is 1. Log 100 is 2. You don't have to write this all the time. It's something that after today I would like you to remember. So if I go to log 1,000,
It's 3.
how come? See it in your mind. This must be 10 to the power 3. That'll go to the front, and the log 10 is just going to be 1. So we now know that log 10 is 1 because we know it's 10 of 10. It's actually this rule. Are you getting into it? So that'll be 3. Tell me what is log 1 over 10? It's 10 to the power
So isn't it 1?
negative 1. That'll go to the front, which will make it negative 1. Check your calculator. Put in log of 1 over 10. Okay? Even if I write it in decimals. Because that's 1 over 100, right? And 1 over 100 is 10 to the minus 2. So this answer should be minus 2. So 1/10 is negative 2, 1,000th will be negative 3, etc. So depending on how many tens there are, so say for instance it was log 10 whatever, it'll be. But your calculator will do that for you because it's a number. So the moment that you've got log 10, 100, 1,000, or 1/10, 100th, whether it's decimals or normal fractions, that would be your answer. All coming down to log 10 because it's 10 of 10, that is 1. Are you with me here? Okay, nitty gritty, extra, over the top. Okay, then there's some other laws as well. So, okay, before I erase it, that's why I left it here. Could I not have done this sum on another way then?
You could have.
Okay, I'm going to erase it now. This was done by going to exponent laws. And then all exponents. Let's not go to exponents. Let's do something else here. Let's make the 4. Let's make the 4 a 2 square.
Yeah.
And if it's a square, what can I do with it? Take it to the front. And what's log 2 of 2? That's 1. If you knew it. So that answer would just be 2. And my answer truly, same as just now, still equal to negative 2. But if I know stuff, I can use it. So I'm just giving you a basic, very basic few rules that you can maybe sometime ever use. But we're not going to go into the difficult stuff. There's rough stuff in the log equations, and there's even log inequalities. Guys, if you know the rules, you can use them. But it's not worth going into the syllabus and practicing that for hours on end for maybe 2 marks somewhere. Are you with me? Okay, there's a few other log laws, just like you knew your exponent laws, right? Exponent laws said that if I time and the bases are the same, I keep the base and I add the exponents. And when I subtract, when I divide,
You
I
subtract.
subtract. Are you with me?
Yes, ma'am.
So if logs and exponents go hand in hand, there should be a law for that as well. Okay, so the law, just like with the inverses, go exactly the opposite way around. If there's a log of something, and now keep in mind, those bases must be the same. If they are the same, then I can put them together. But now there were laws in exponential, let me write it again. In exponential expressions, the laws were if I time, I have a law. If I divide, I have a law. If I add and subtract, there was no law. You had to factorize. Are you with me? This changes. The law is if the two are separate and you want to put them together, you can if it's plus, but not if it's times. Opposite. Okay, so the law is, guys, this is way over the top. So we've got log to the base of A, log to the base of A is going to be 1 log also to the base of A. Then guess. What am I going to do with M and N? You're going to times it. It's the opposite of exponent rules. You're going to times it. So it's going to be M times N. If you want to show yourself, it's the times there. And then what do you think is going to happen? What doesn't matter what those values there are, but it has to be the same basis. Then I can put them together. If it's minus, it's going to be, what do you think? Ah. You're not going to use this, guys, okay, to show you that the exponent laws has now got log laws, but it's completely different. You did not have any laws for adding and subtracting, you were factorizing. There is no laws for multiplication and division here. Are you with me? That is over the top for free. Extra work. Are you with me here? Okay, we can have a look at a few examples just so I don't just give you a lot of information and don't do anything about it, but is this examinable?
No.
So why am I doing it? To waste your time?
No.
Guys, there are some of you that are going to need this. And it's actually interesting. But these log equations can get rough. Okay, I'm not going to go there. All right, rough and tough. Let's see. Just for interesting sake. So if I tell you to go and solve for x in the sum, what option do you have?
Is it times those things?
You will time them. It's this law. Guys, it's not actually examinable. So this is going to be log 16, because what did you do? If the two separate logs are added, then when you get them together, and the base?
It's
It's
10.
10. It has to be the same, and in this case it was 10. Then you take the 8 and the 2 and you multiply them. Then we got log x to here as well. Ideas. Take the 2 to the front and then? Because it's true. It can go stand in the front.
Take the log, like that thing, and make it a negative.
Divided by log.
Deduction.
Please don't say that. You're making
A logical deduction.
Still.
Exponential.
Are you with me? And then x would be equal to? But are those things supposed to be negative? Please go to your calculator and tell your calculator to do log negative 4.
Can't do it.
Man's game.
Error. The definition is whenever I've got y equal to log a x, that can never be
1.
and neither one of them can be negative. So that guy that forgot about the plus minus is absolutely right, because it cannot be a negative if you're inside the logs. Right. All right. So how would you approach a sum like this now? Divide. By 5. That's what the calculator is going to give you, 6 over 5. And then what? Up to now, you've always had equations that have exponents that are variables as 3 to the power, 3 to the power. It's not going to happen. Now you have another 2. You've got the
Log.
logs. So to get your exponent, you're going to say log
3.
3.
6 over 5.
If you forget how, which one? You go back, it's not there on the board anymore. 2 to the power 3 equal to 8. Take it to logs, make sure, so that you know that you've got it right now. And then what? This sum would have said to 2 decimal places, because there's no other way of doing it. And please give me an answer on the calculator for this.
0.17.
Is it 1/7? Okay, let's not round off yet because we still have to divide. So 1/7, I don't know what.
165.
Okay, so then when we divide by 2, now we'll round off. Please?
.0.08.
8. Rounded off correctly. Okay, and that's it, guys. So if you're not able to do it anymore, like in grade 11, that the bases get to be the same, then you've got a new tool. Now you can solve it. And it's not brain surgery, it's just a new tool that you've got to be able to use. It's nice and easy. Do you agree? Okay.
Okay, now I'm